Hi everyone, I am Mrs. P. Muthumari, currently working as an assistant professor, Department of ECE, Kamaraj College of Engineering and Technology, Virudhunagar. I hope you all enjoyed by watching my previous videos. In this video, I am going to discuss about voltage division rule as well as current division rule. Wherever voltage divided, we go for voltage division rule. So, when the voltage division occur means the series circuit acts as a voltage divider. So, let us see this voltage division by using small example. Single voltage source with two resistances. For example, we can take 10 volt as a source voltage, 2 ohm and then 4 ohm. The series circuit acts as a voltage divider. Since the same current flows through the series circuit, the voltage drops are proportional to the value of or the amount of the given resistances. So, by using this principle, the two branch voltages occur here, voltage across 2 ohm resistance as well as the voltage across 4 ohm resistance will be calculated by using voltage division rule. The voltage across 2 ohm resistance we can calculate by using total voltage multiplied by the particular ratio. This ratio numerator amount is the same resistance divided by the total resistance. Can get into clear. The voltage across 2 ohm resistor is the total voltage 10 volt multiplied by the same resistance is 2 ohm resistance multiplied by the total resistance is 2 plus 4 6 ohm resistance. Then 10 volt divided by 1 by 3 which is equal to 3.33 volt. Then the voltage across 4 ohm resistance is by using the same rule, total voltage 10 volt multiplied by the same resistance here is 4 ohm. So, 4 ohm multiplied by the total resistance 6 ohm, that 10 volt divided by 2 by 3 which is equal to 6.67 volt. So, the 10 volt can be divided in two branches, 2 ohm as well as 4 ohm. Voltage across 2 ohm resistance is 3.33 volt and then voltage across 4 ohm resistance is 6.67 volt. By adding this 3.33 plus 6.67, we can get the source voltage 10 volt. So, by using voltage division, different voltages can be obtained, voltage across 2 ohm as well as voltage across 4 ohm. By using this principle also, we can verify Kirchhoff's voltage law also. By using voltage division rule, we can verify Kirchhoff's voltage law also. What KVL states that sum of voltage rise equal to sum of voltage drop, otherwise the algebraic sum of all branch voltages around any closed path which is equal to 0. So, that is why the branch voltage 3.33 addition with 6.67 will give the resultant voltage as 10 volt. So, by this we can we verified, by this we verified KVL also. Now, we can add one more branch this previous one. So, now we can have 3 branches, 3 ohm, 4 ohm as well as 4 ohm resistance. So, now we can find V across 2 ohm, V across 4 ohm as well as V across 4 ohm. So, first the voltage across 2 ohm resistance is the total voltage 10 volt multiplied by the same resistance 2 ohm divided by the total resistance 10 ohm. The resultant voltage will be 2 volt. By next we can identify the voltage across 4 ohm resistance, that also followed by same principle, total voltage multiplied by same resistance divided by the total resistance 10 ohm, it will give 4 volt as a result, and then the third 4 ohm resistance will give the result as the same 4 volt here. So, the total 10 volt can be divided into 2 volt, 4 volt as well as 4 volt. So, in this voltage division rule we can add n number of resistances. So, the number of resistances cannot disturb our basic rule, total voltage multiplied by the same resistance multiplied by the addition of number of resistances did not disturb our the basic rule, because the addition of resistances will be reflect in the total resistance itself, the denominator only varied. The addition of n number of resistances will also give the better result in voltage division rule. We can add fourth resistance also here. The total resistance only varied. The same resistance occupy the original value. So, the addition of resistances did not affect our original rule. Okay. Next we go for current division rule. When the current division occurs in a parallel circuit, always current division occurs. So, when we have a parallel circuit here, in this parallel circuit 9 milliampere acted as a source voltage, 3 ohm as well as 6 ohm act as a branch resistances here. So, in this we can find the current flowing through 3 ohm as well as 6 ohm resistances. First we have to find current flowing through 3 ohm resistance, it is named as I1, 6 ohm resistance named as I2. Okay. By using current division rule, we can identify the branch current. So, by branch current equal to the total current multiplied by the ratio how we can calculate the branch currents by using current division rule here is the total current multiplied by the particular ratio. The ratio is the opposite resistance by the total resistance. So, wherever we can find the current flowing through the 3 ohm resistance is the opposite resistance is 6 ohm, we can find the current flowing through 6 ohm resistance is the opposite resistance is 3 ohm resistance. Okay. Now, we can write the formula here. Branch current equal to the total current multiplied by opposite resistances divided by total resistances. Two branch currents here. So, I1 or I flowing through 3 ohm resistance here is the total current given 9 milliampere, opposite resistance here is 6 ohm divided by the total resistance is 9 ohm, the addition of 6 ohm plus 3 ohm, the total resistance is 9 ohm. Here the resultant branch current is 6 milliampere. By using the same rule, we can identify I flowing through 6 ohm or I2. I2 here is the total current 9 milliampere multiplied by the ratio, the opposite resistance of 6 ohm resistance is 3 ohm multiplied by the divided by total resistance is 9 ohm. So, we can get the result is 3 milliampere here. So, the total current is 9 milliampere, we can get the branch currents here is 6 milliampere as well as 3 milliampere. So, by using current division, we can verify Kirchhoff's current law also. So, the current entering into the particular node which is equal to current leaving from that node. So, in this node current entering here is 9 milliampere. So, leaving from this terminal I1 as well as I2, I1 is 6 milliampere as well as I2 is 3 milliampere. So, here Kirchhoff's current law is verified, 9 milliampere equal to 3 plus 6, 9 milliampere. So, in this current division, in this rule particularly applied for only 2 branches. So, we can add one more branch in this scenario. In addition of the third branch 3 ohm resistance here, we can find I1, I2 as well as I3. So, I1 here is the total current multiplied by the particular ratio. The ratio numerator is opposite resistance divided by total resistance. That opposite resistance is 6 ohm parallel with 3 ohm. So, 6 parallel with 3 will be act as a opposite resistance of 3 ohm resistance. So, 6 parallel 3 acted as a opposite. This total resistance, this 3 ohm addition with the opposite resistance 6 parallel 3. So, 6 parallel 3 will give the result as 2 ohm resistance. This 2 ohm resistance addition with 3 ohm resistance here is 5 ohm, right. So, the resultant current is 3.6 milliampere. This will be I1. So, next I2 we can calculate. So, I2 here is 9 milliampere multiplied by the same ratio opposite resistance multiplied by total. Here the opposite resistance of 6 ohm resistance is 3 and 3 parallel. So, 3 parallel with 3 will be acted as opposite. This opposite resistance addition with the same resistance 6 ohm here is, so 9 milliampere multiplied by 1.5 ohm by 7.5 will give the result as 1.8 milliampere. So, here I2 is 1.8 milliampere. By using same rule, next we can find I3. So, I3 I flowing through 3 ohm resistance. So, the total current 9 milliampere multiplied by the opposite resistance here is 3 parallel 6 will be the opposite of this 3 ohm resistance. So, 3 parallel with 6, the result is 2 ohm. This 2 ohm is opposite resistance, then divided by total resistance 2 plus the same resistance 3. So, the total resistance will be 5. It will give the result as 3.6 milliampere. So, I1 is 3.6 milliampere, I3 also 3.6 milliampere, I2 is 1.8 milliampere. By addition, this 3 currents will give the result as 3.6 milliampere plus 1.8 milliampere plus 3.6 milliampere. It will give the result as our source current 9 milliampere. So, by using this we can verify our Kirchhoff's current law also. At this junction we give 9 milliampere, it will divide into 3 branches. So, first branch is 3.6, second branch is 1.8 as well as third branch is 3.6. This 3 current will give the source current 9 milliampere. In this we can verify Kirchhoff's current law also. Thank you.